In this Elektor Engineering Insights Special, I'm going to be asking 3 questions of Dr. Ernst Flemming and Jithu Abraham to find out how they can measure extreme electrical signals with their new range of Rohde Schwarz mixed signal oscilloscopes.
So first of all, we introduced 12 years ago with the first oscilloscope range, starting with the RTO, and at that time introducing the fastest oscilloscope to the market. That was ranging up to 4 gigahertz. We now solidly built and introduced new instruments so that we have a range starting from the handheld, which has isolated input, so it's very good for power applications. And then we have it from the lowest class, 1000 class, up to 16 gigahertz performance class oscilloscopes. That's the range where we always try to build on innovative products, build fast, concentrate on user needs, on engineers' needs, so that we can get fast results, accurate results. So that's our positioning. And of course, that's very well matching with the overall test and measurement perspective that Rohde Schwarz is offering. So we call that more affordable, we call that essentials. And there is something behind that because it's an essential product that is at everyone's desk, every engineer's desk, doing general purpose electronics debugging and problem solving and analysis of electronics. So that range is a little bit different to the performance class in such a respect that it is like really optimized and tuned for an affordable essential product, and therefore it really needs to be priced so that people can get it easily and can work with it. On a performance oscilloscope, we focus really on the solution that is an attractive offer to the engineer, solving their problem, addressing their problem. It's really optimized for the lowest noise, for the highest update rate, and of course for deep memory applications as well. On the essential range, cost is more critical, that's one thing, and on the other hand, the distribution is different. So on the performance class, users typically tend to get lots of software options, lots of specific solutions and probes. So this is a complex product that needs a sales engineer, a detailed discussion, including application engineering most of the time, so that at the end we configure the product to the needs of the customer. On the essentials, this is more a standard product that has maybe a few options, if at all, few probes, so it's very easy to get it to everyone via our partners, channel partners that sell it, that are able to reach the customer very close and very fast.
Sure. We have today the MXO4, and really it's different from what Ernst mentioned before. We have a wide portfolio, and it's really a new generation of instruments that we are building upon new technology blocks, if you may, that help get accelerated insight to the engineers. So for the MXO4, we have a new name, the MXO, and a 4 for the series of scopes that we're bringing out. So this is a new family of scopes, if you like, in the 4000 class segment. Now with this scope, we performed a lot of innovation blocks, if you like, and so on. Things like to make it really simple and easy to use, but also being extremely fast. So that was one of the key design goals, if you may, that we had with our RTO class of scopes, which, as Ernst mentioned, was more in the performance class, but really bringing that down to the 4000 class, if you like. And this was achieved by a new custom designed ASIC by Rohde Schwarz. So we have it as the MXO EP, so EP for extreme performance, and this is really the heart of the instrument that really brings us all the performance elements that we can see down to the bench, down to the user. And what this helps is giving us a really fast instrument We measure this on scopes by a term called update rate. It's kind of like refresh rate on a monitor or so on. And this helps the scope understand I'm capturing something, trigger on it, bring it as quick as possible to the display and get the next one in. And so we've reduced the processing time that we take from the capture and then putting it into display, if you like, to get the update rate up to 4.5 million waveforms per second. So the fastest we had before was in the RTO with 1 million. Now we're exceedingly faster as well to mainly get those insights of your signals. Because largely, if you're looking at a signal, you might think all is good and all is well, and scopes are normally used as a visualization tool to really find what might be going wrong. And everything looks great and rosy, but is it really the truth? So, the fast update rate really gives that insight into what's happening. But of course, it's a test and measurement unit, so we have to be extremely precise as well when we're capturing signals, be it probes, be it going down into the boards itself. So we have a new 12-bit ADC that is working at all settings, if you like, full 12-bit all the time. And for those users who need more resolution, we can go up to 18 bits by our HD mode. So this allows users to really tweak bandwidth and so on to get more resolution when they need it for power supply designs or for really looking at details for a signal. All of this is great, and we also have new components to really bring down the noise flow of the instrument really low. But also, it's great that you can actually visualize the signal, but a big important factor for our designers was, can you trigger on those signals? So we're launching as well what we did do 10 years ago with our new digital trigger in the performance class. Now we're bringing it into the 4000 class. So really, it's like very, very sensitive trigger. So even small, minute details on a signal can be triggered and captured reliably, and it's completely configurable of how you want this sensitivity to be. So get rid of noise and so on, just really go down to the details so you can really make those measurements possible and repeatable. And the last thing we focused on was scope users love to capture a lot more in time. Everything is time-based, it's a time domain instrument, and they love to capture more in time. So for those users, we have about 400 megapoints of memory per channel. That means you can capture large amounts of data and not sacrifice sample rate and so on to then degrade the signal. So you can really then capture loads of time, record that data, zoom into the details if you need to, and find out what the system might be doing over a period of longer time. And that's useful for a lot of different applications and so on. But the last thing that we did on the scope is enhance the UI element of it, because it's great to have all these features, but if you can't operate the instrument, you failed probably bizarrely bad. So with the instrument, we have what we launched last year with the RTO6 scopes. The new UI element is also on the MX04. So it's really a cohesive UI, if you may, from somebody who's using a 4000 class to the upper range as well. So we're really proud that people can have a much shorter learning curves. It's much smoother to operate the instrument, and you're really focusing on what you're trying to test rather than trying to learn
class of instruments. So the first and main purpose is actually something we call hardware bring up, checking on the voltage, checking if everything fine. And for that, the fast update rate is really, really a great tool, because you see rare things, and at the end, your task is done faster. So that's actually a very important message to the people, and that's what they jump on the engineer. So that's one thing. As I said, in general purpose, but of course general purpose means be it an ECU in automotive, be it an IoT device, be it something in a consumer electronics. So it's really the whole complete range of that. So that's one of the applications. When you think now about the accurate low noise performance, 18-bit vertical resolution. This is something where it's beneficial if you think about really small signal details. So you have that one example in power integrity, power sequencing. Those are applications that are important or where we offer important benefits, put it that way. And then on the other hand, it's like in IoT, you have always small currents, small voltages, small voltage changes. And this is something where you can really tweak the detail and benefit from the digital trigger in such a way that you can isolate those small changes as well. So those are examples where you really have a big benefit on the 18-bit resolution as well as on the digital trigger. Thinking about the deep memory, there's an easy answer. Like, it's very typical, very common that you do a long recording. For example, in automotive, when you have a CAN bus, you want to do the full recording over a second or even longer, and you don't want to, and you want to decode everything and then want to search in the telegrams and look for any problems there, be it on the software side, be it on the hardware side. So that's something you will not be really happy without that deep memory on the one hand, and on the other hand, when you do it without that extreme performance chip, you fail because the scope itself is really slow because it has to do everything in software, and that is really slowing down. So here on the hardware-based solution, you can be still effective when you work on deep memory. That's one of the examples. The other example is when you think about power sequencing, you have a power up sequence, you do several voltage rail measurements, and on those you want to check on any dip when you start another component on your system, and that's easily possible without any bandwidth trade-off with the deep memory. So you record for seconds for the full boot time, and based on that you can really check all the details without any drawback in the, what I would say, drawback in bandwidth or so. So you really see all the details.
So here we have the new MX04 series oscilloscopes. It's floating at the moment because I have a Weezer mount that comes standard on the instrument, so I can squiggle it around, get more bench space, if you like, for what's more important, like boards and other things and so forth. The instrument is really silent, so this was one of our design goals, if you like, so that we minimize any fan noise and things like this, so that really you can concentrate on finding those signals and so forth. Very portable instrument as well. There's obviously lots of I/O interfaces like USB, Ethernet at the back of the instrument, HDMI to bring it to a bigger screen and so on. And of course a nice big screen as well. So this is now a 13.3-inch full HD resolution screen, and of course fully touchscreen as well, so if you did want to change parameters and so on, you can do so very quickly. Of course, for those engineers who love hard keys as well, we kept a nice selection of different hard keys as well that relate to what the signal is doing, what you're capturing and so on. Now for this instrument, I want to show you why we have these three key elements that help engineers. So I'll start off with being really fast. So I have connected the scope to a board here that's actually supposed to be a really clean square wave, but it generates out about 4 errors per second. So randomly those 4 errors come up every second, and on a traditional scope like we have here, you rarely see those errors pop up. So this is down to the update rate of the scope. Maybe once in a while it might capture these errors, but the probability of capturing those errors are much higher. With the MX04, you have about 4.5 million waveforms per second, always trying to capture at the fastest speed. And now you see all those small glitches, different run sizes and so on come up and appear on the scope, so that you can really find all those signal details and debug what actually is going wrong with the board. So that helps not just in terms of just the fast update rate, but also in things like having a smooth UI as well. So our ASIC helps us to help us get the best performance for the signals and so on. So if you wanted to move things around and so on, it's just easy and fluid to use. The other point that I wanted to touch upon is on the low noise parameter of the scope. So if you disconnect everything, you can actually measure how much the noise of the scope is, and it's really, really low. So if I do a preset and then bring it down to the lowest setting, you can see that about at 500 microvolts, you see the amount of trace noise that is there on the scope, and it's really, really low for the particular setting that you have. So for the small details, you can switch all the way down to 500 microvolts per division, so that you can see any kind of changes in your signal that are in the microvolt range. I wanted to show you this on a real signal. So if you had, say for example, a sine wave, let's go ahead and bring up the signal from the generator. You would see in a traditional scope, you would see this like this. It looks like a regular sine wave. We've now done a zoom on the top of that sine wave. And if you had a scope which is quite noisy or much lower resolution, like an 8-bit scope or so on, you see this just like a fat line around the sine wave. Now actually the generator is generating a very tiny small sine wave on top of this big one. So with our scope you get the full 12-bit ADC resolution all the time. However, for such applications you might need a little bit more. So you can enable now the HD mode, and the scope always tells you what the resolution is. Now we're at the full 18 bits. And if you notice on the sine wave, now we can actually see this small, minute sine wave that is on top of this, the bigger one. So really, to pinpoint these details and so on, this really helps to get you the best resolution possible. And the other point that I wanted to talk about was our new digital trigger that allows you to actually pinpoint, once you really see these details, how can I reliably trigger on a signal. So I have another example here where I have a large amplitude pulse and some smaller ones down there. And largely I would like to trigger on these smaller ones out there. So traditionally I would just change my level. So right now I'm triggering bang on in the middle of the screen. If I change my level to something down here, I cannot trigger on this particular signal. This is really because that I don't have enough sensitivity to really tell the scope, look, I want to go down to those details of that signal. If I unlock this on the standard trigger mode, now I'm actually can go back to the big trigger, or I can actually see that I can go all the way down to this small pulse and even down to the smaller ones as well. So really, really, this is now down to the millivolt range that we're actually triggering reliably on these minute details and so forth. We can combine this with the HD mode as well, so that we can get rid of, you know, high frequency noise and so on, to really go down to what we need and get the more resolution that we require. The last point I want to touch upon is the deep memory of the scope. So if I bring up a signal, traditionally on scopes, most users love to capture more in time. And so in here we have a signal that's meant to be a square wave, and we wanted to capture about a second worth of data. So you can see that on the top there, we're capturing a second worth of data, and we're performing a zoom just around the trigger point to see if we're actually reliably capturing this. And as you can see, once I perform the zoom, my signal doesn't look anything like a square wave. And this is really down to the scope not having enough memory. So you see there's about 900 kilopoints of memory, but this really doesn't help because I've now had to trade off my sample rate. And this is very, very annoying for a user because all they care about is I just want to capture 1 second. So now if I tell the scope, look, ignore my previous setting, use the full memory of the scope, you can see now we're close to 700 or close to even the full memory depth of 800 megapoints. And now we're capturing 1 second, we can zoom in, we still see the actual resolution of the scope, of the square wave, and not trade off anything from doing this. Even at this really high memory depth, we still have a very responsive system. So if I change any of the parameters or so on, I can really operate the instrument just like how you would do normally without any trade-offs and so on, even at this really fast deep memory mode.
So that's all we have time for on this edition of Elektor Engineering Insights. If you'd like to stay up to date on the trends in the electronics and semiconductor market, please hit subscribe, and while you're there, give this video a like too. And if you've got a topic you'd like to discuss, reach out to me, Stuart, on LinkedIn. See you next time.